If you don't have any questions, then I will start discussing some more example.
Okay, sir.
Any
So where
question?
will you find these examples, like in this book which you recommended? That
Sarthak, I am not able to. Can you just tell loudly a bit?
sir, am I not audible?
Yes, you are audible, but be a little louder.
Sir, am I,
Hello?
is it clear?
I can listen you. Tell me.
So like where would you find more examples for the same thing which you told last class, like those, like now which you're gonna give,
I
like
will I will again discuss you more examples.
are there in any book to practice if there?
Uh, I don't think you will be able to find, but I will give you some tutorials, and then I will discuss more of them in the lecture.
Okay,
Okay,
sir.
today I will do some more practice. Okay.
Okay. Yes.
Anyone else? Any questions? No questions. So let me go ahead. Okay. Just 1 minute. I think I will. Okay. So. Okay, so what I will do that I will start again discussing few more questions. Okay, so let us go and discuss few more examples. Give me 1 minute. Okay, so this is a question. You first try and then I will help you. Hg 2 2 plus plus TL3 plus. So this is the and give you 2 Hg2 plus plus TL plus. Okay, and the rate is given is equal to K Hg 2 plus TL3 plus divided by Hg 2 plus. Okay, now tell me what will be the mechanism. How will you go ahead? Think about this. The first question is, how many steps you can think of? Can you tell me?
So when in the denominator there are two terms and there are two steps, but over here there's one term.
One term. I told
Yes,
at
sir.
least two steps.
One.
You see, at least two steps. Right?
At least two steps.
Can have 5 steps also. At least 2 steps. Please keep in mind. Remember that this may have a term plus something which you are not able to see because
Or fast reactions or
yes, you are right. No, slow reaction.
slow reactions.
Right? Now think about this. This is what? Product. So where it will be formed?
Before the
Before the
intermediate.
last
Before
step.
the-
Last
yeah,
step.
before the rate determining step. So at least you have 2 steps. Okay, so sometimes you have to, use common sense here. So what will be here? Hg 2 plus.
So now
Right.
balance the atoms. Yes.
Now, so it means that if there is 2 steps, there will be some K and there is something here. Okay? And then this can be neglected. That's why you got it here. Now, now second thing is, I know that this is Hg2 plus. Now think of what will be the what will be the composition of the reactant in RDS?
So when we'll balance
Hg2.
it,
Tell me how many Hg?
one Hg.
1 Hg. Because there are 2 minus 1, 1 Hg. How many TL?
One.
One.
1. Okay. And what should be the charge?
3.
3 plus.
Plus 3. Okay. Plus 3. Now tell me. Here Hg2 plus has formed. Am I right? So there should be one intermediate here. So this is I. Alright. And then there is I. I can have 2 terms because even if there is one more term, then it will be neglected. Am I right?
Yes, sir.
Okay. What can you think of? Hg1.
Hg plus 3.
Hg2 plus is the product. Alright.
Yes, sir. So Hg
So
plus
this
3.
Hg2 plus will form from what?
Hg2 2 plus.
Good. Hg2 2 plus. So
Sir,
what
I will be with Hg.
Hg. और यहाँ पे Hg हो गया फिर because intermediate
TL3
here
plus. TL3
plus
plus.
TL plus 3.
plus 3. Is this satisfy this thing? 1 Hg, 1 TL and charge 3 plus.
Yes, sir.
Okay, so what you will get here?
Hg2 plus.
Hg plus 2. TL plus 1.
Plus. And then balance it. You'll get the same equation. Alright? This is the way you can go ahead and try to get the mechanism. Simple way. Sometime if you have some doubt, you can think of another way. That is also possible. Only thing you need to make sure that this has 1 Hg, 1 TL and 3 plus charge. You cannot have a mechanism where there is 1 Hg, 1 TL and 2 plus charge. That is not possible, simply not possible if this is the rate law. Okay, so you can think of how many mechanisms which you can think of can be eliminated. And you are only left with 2, 3 which you can think of. And then you can do other experiment. For example, you can look at the, like there are TL3 plus. If there is some test for TL3 plus, you can think what TL3 plus is there. Some test for example, Hg, simple Hg, not Hg2 plus. Then you can see whether Hg has formed or not. So those things you can do, but this is simple way to get a mechanism. Now let's go ahead and see if we can do more. Okay, have you heard about unimolecular reaction? You must be knowing that there is a unimolecular reaction, right? Unimolecular reaction,
Yes, sir.
right? There are a lot of unimolecular reactions. Okay. Now question is, if there is one A, is it directly going to P? It will not happen. A must collide with another A before a product can form. Then why a lot of reactions are first order? This is the question. Because A must collide with A, then only a reaction will form. But if A collides with A, then what will happen? There are two A involved. It means rate should be
A square.
K into A square, am I right?
Yes, sir.
That is a possibility. Then why lot of reaction of first order? Or unimolecular reactions are first order?
Sir,
Question always comes.
if it's happening in water, then we can even ask the same question as A is reacting with H2 and forming P. How will it be different?
Yeah, certainly. You can always have this kind of question, that any first order reaction, how it can happen? Because A must be colliding with another particle, another species. For example, so this is I am talking about gaseous reactions. Even gaseous reactions, how they can be first order. If there is no solvent, they can also be a first order reaction. But we know that unless they collide, they will not get activation energy.
So due to
At least
de-energization,
what?
due to de-energization,
No, let me explain this. So this is so first time this is explained by Lindman, and so this is known as Lindman's hypothesis. Okay. So what he was able to see, that any unimolecular reaction in certain condition acts as second order reaction, and in other condition it acts as unimolecular or first order reaction. Now most of means every, I'm talking about every first order reaction. So how that can be explained? That can be explained by this kind of equation. Rate law. I am now writing rate law. Okay. Rate is equal to Ka square by K dash A plus K double dash. Okay. Now think of, I am considering this only. Then under certain condition you can write like this. Right. Now suppose this K double dash is small. What will happen in that case? This A cancels out. Now order is? क्या होगा order?
First order.
K dash A. And order is simply 1. If just opposite, what will happen? Order is?
Opposite order 2 हो जाएगा.
Order is equal to
Second order.
second order. So now you can explain that a reaction can be first order even if there is a collision between two A molecules. Now, from that, can you propose a mechanism? This is the rate law, right? Now let's think about what can be the mechanism. अब सोचो जरा इसको and tell me what can be the mechanism.
Should we? Is it necessary to know
अभी
the
सोचो
case
एक बार.
K
Yeah.
dash K double dash बड़ा है कि छोटा है, ऐसा कुछ डेटा गिवन रहेगा या फिर
नहीं, under certain conditions I will discuss when that
Okay.
can be K dash can be K double dash can be very smaller than K dash A, and when K dash A will be very smaller than K double dash. But first think about that this is the rate law.
Okay, sir.
Am I right? And that is going according to our experiment, right? Under certain condition it is order 1, and under other condition it is order 2. That can only happen if we have a rate law like this. Is it okay? For example, now K dash, if I neglect this K double dash, then this is first order, and if I neglect K dash A, then this is second order. Similarly, you can think of any reaction which is third order with A under certain condition, and second order, then what will happen? There will be Q here, and then this will be like this. Right? Same same denominator, and numerator will be Q. Right? But for unimolecular reaction, what people generally saw, Lindemann first time was able to show that under certain condition, I will discuss the condition, but once I give you mechanism, then I will discuss the condition. Under what condition order will be 1, and under what condition order will be 2. In fact, he was able to observe under those conditions, and then he come up with this this rate law. Okay, this is very well explained. The mechanism very well explained why under certain condition order is 1 and under a different condition order is 2. So please think about this. I have already told how to do that. So what will be the reactant? Let's think about this. What will be the reactant in this case? क्या होना चाहिए? A plus A. Gives you what?
An intermediate plus A.
One intermediate
And A.
plus A. So what will be the intermediate? Let's put A star. Right? This A is formed here. You see, this A is here. Okay? Now think about it. This
So
I,
A
which is
star
A
to
star,
P
goes to
P product.
There should be 2 step, and there is 2 step here. There is A term here, so you can write here A, and then you can write this whole thing.
Sir, I have a doubt here. Like, आपने रेट लॉ में अगर हम A को बैलेंस करेंगे तो हमारे पास एक A होगा.
Yeah, in which?
In the rate law, if we balance A, like in denominator we have 2 A's and in numerator we have 2 and in denominator we have 1. So total A would be 1, right? If
No, this is A star, no? This
in
is
rate law.
also
In rate law.
in the rate law, okay?
तो A एक ही होगा ना in rate law.
आप ऐसा सोचो ना, this is take this. This is second constant. If you neglect this,
Yes, sir.
what will be the composition of A? Composition of reactant in the rate determining step. There should be 2 steps. Am I right? Because there
Yes,
are 2 terms. So that's what I wrote here.
Sir, in the second step, shouldn't there be one additional A in the
Yes,
second
sir.
step?
Okay, if you think like this, if there is one additional A, Okay, if there is one additional A, suppose here, there will be 2A in this thing. Am I right or not?
Yes.
There will be 2A.
Yes.
Okay. Then what you expect? That A2 is formed? What will you expect? Either A2 is formed or
No,
true
sir.
of this kind of. Yeah.
I'm saying like if we directly add these reactions, then it should also give that above reaction, right? A plus A gives P.
A star plus A gives B. You are right. What I
No,
am
sir.
saying,
The
okay,
above reaction,
okay,
the first order.
in this one,
No, the basic reaction, the
RDS,
mechanism. A plus A gives P.
A plus A gives.
Since
P.
Lindsman hypothesis, when you wrote that, over there
The
he's saying A plus A gives B. That उसके साइड में आपने लिखा.
नहीं, एक मिनट. Ayush, you are talking. Am I right?
yes, sir. Sir, this is
Okay.
the mechanism of that reaction, right?
ये देखो, this is rate law. This comes from experiment. Experiment suggests that in under one condition, this first order, another, and in another condition, it is second order. So rate law must be this. Is this okay? Till now?
Yes.
Now
Yes, sir.
I have to find mechanism. Okay? So A plus A, we are saying A plus A, certainly 2A must be involved. It cannot be from one, it cannot come, right? Because this is unimolecular reaction, there is nothing else here. So first step must be A plus A. There is a chance that A plus A goes to A2. Then A2 is intermediate, am I right? Then you cannot account for this A. Can you account for this A? So let's write this A. Since this A can be either reactant or can be a product. Right? ये हो सकता है.
Yes, sir.
Yes.
ये तो intermediate हो गया A2 plus A. Then you are saying product. Now again, suppose it is giving A2 plus A product. Now let's go here. किसको आप neglect करोगे कि A3 आएगा? इसको भी neglect करोगे? Suppose this A is involved, so this is reactant. So this is K dash. अगर neglect करोगे तो क्या आएगा? Is it possible?
No, sir. I was saying something right. A plus A gives I. A plus A gives A star plus A, and then A star plus A gives P.
Okay, so you are saying like this. Am I right?
Yes, sir.
A plus A gives A star plus A, or A star plus A gives P. That's
Yes.
what you are saying?
Yes.
In that case, what do you expect here? There should be one A more. Because this has formed and this is also involved here. Intermediate के अलावा क्या है? A है. Here intermediate is reacting with A to give A plus A, reverse reaction में.
Yes, sir.
Here intermediate is reacting with again A to give you P. Then K dash A plus K double dash A होना चाहिए था. आप समझ रहे हो? इंटरमीडिएट किसी एक ही टाइम A के साथ रिएक्ट कर सकता है. Otherwise you can simply write a rate law and you can see here. If you are proposing this one, then there must be one A here. Then only you can get this kind of reaction. दो तरह से हो सकता है. ये A either reactant हो or product ho. That is the possibility. But it cannot be both reactant and product.
But sir, if there is one more A with K double dash, then A can be taken as common and it will be A into K dash plus K double dash. So constant into A. So there will be just one constant multiplied by A, right? If we take A constant, मतलब A
No, you are
common.
talking about this mechanism.
Yes, sir. In the rate
अभी
law.
जो लिखा है,
Yes, sir. Yes.
आप करके देखो जरा क्या
Sir,
आएगा.
I was just saying that if we add these two reactions, then total we will get 3a plus a star on the left hand side and a star plus a plus p on the right hand side. So after cancelling we will get 2a on the left hand side and 1p on the right hand side, and this was the first order reaction whose mechanism we were trying to make.
Again molecularity पे चले गए तुम. Okay, so let's add it. मैं तो कर रहा हूँ ये रेट लॉ से मैच ही नहीं करता. You are talking about all reactions, am I right? I am talking about rate of reaction. I am talking about rate law. So let us see what you will get dA star by dt. चलो करके देखते हैं. What I will get? Tell me. You tell me. K1 A square. ठीक है?
Yes.
Minus A minus 1 A into A star.
Yes sir.
ठीक है?
Yes sir. Minus K2.
क्या लिखोगे? A into
K2 A star. Yes. A star into A. Yes.
Just 1 minute. Sorry. तुम अपने से करो तब तक. लेट मी ट्राई टू ओपन दिस वन मोर टाइम. खुद करके देखो
अच्छा ओके सर.
क्या आ रहा है. Okay, I have to write again. Okay, so what we discussed that this is the rate law. Let me write first rate law. So rate law is equal to k into a square by k dash a and plus k double dash. What you are saying that a plus a gives you a star plus a, and then a star plus a star plus a gives you, this is the rate determining step T. Okay. Now let us see dA star by dt. dA star by dt is equal to k1 a square minus k minus 1 a star a minus k2 a star a. This should be 0. So a star is what? That's what I was saying, that k1 a square by k minus 1 a plus k2a. This okay? And dp by dt should be then dp by dt is equal to k2 a square, k2 k1 a square a star into a hoga, am I right? k2 a star into a. So
Yes.
this will be what? k2 K2 K1 A cube by K minus 1 A plus K2A. हो गया या नहीं होगा?
हाँ, yes.
A cancels out. तो एक में नहीं हो सकता है. You know, either this A is as reactant or as product. That's what I was saying. You cannot be at both this. अगर होगा तो ये दोनों में involved होना चाहिए. जो intermediate है वो इस पे डिपेंड करेगा. Intermediate is going to react with A only one time. यहाँ पे B होता तो intermediate is going to react with A and intermediate is going to react with B. Okay. So please keep that thing in mind. So there are two steps here. So it means that there is two steps. There are two terms in denominator, two steps, and then you have intermediate here. You have intermediate here. Okay. Now either A is involved here or A is involved here. That is the only things which you can think of. But more logically, if you think, because we have to start with A plus A. So either A2 is formed, then A2 is intermediate, then A2 plus A, which cannot happen because there are three A's here. Right? What is the composition of RDS? अगर A2 मान लो, चलो A2 भी लेकर चलते हैं, तो A2 से बन रहा है suppose product. Okay? If suppose this is the case, A2 plus A, तभी प्रोडक्ट बनेगा. एक को तो अकाउंट करना है हमें, आइदर यहाँ हम लिखे या यहाँ पे लिखे. तो सपोज यहाँ नहीं लिखते हैं तो A2 बनेगा ये, और तो A2 plus A हमने लिखा, right?
Yes.
Now 3A are in rate determining state. Now think of whether that goes according to this. So suppose I neglect this term. How many A? अगर पहला टर्म नेग्लेक्ट करें तो यही होगा ना. इसमें पहला टर्म ये है जिसमें A है, तो इस टर्म को नेग्लेक्ट करना होगा बिकॉज दिस शुड बी ए स्लो स्टेट. सो इफ आई नेग्लेक्ट दिस, व्हाट शुड बी द A composition of A? What is the composition of reactant here in RDS? Tell me composition of reactant in RDS.
There's one A and one A2.
अगर ये हम नेग्लेक्ट करते हैं सपोज, सो व्हाट शुड बी द कंपोजिशन? 2A.
Yes.
और यहाँ पे क्या है कंपोजिशन?
One A.
3A हो गया ना.
ये
A
Just
plus
sorry,
A.
3A.
So is it possible? Not possible. Now think about this. अब मैं क्या कर रहा हूँ कि इसको A लिख रहा हूँ, ये प्रोडक्ट में फॉर्म हो रहा है. सपोज आई assume. Okay. Now tell me what will be here. A ही हो सकता है. Now I am writing A star. Okay. Now since A is formed here, so second step में which one is the slow step? Second step. So this is product thing. So this should be small. If I neglect this, what is the composition of reactant in RDS?
One A.
1A. That is A star going to P. You can only end up with one unique reaction. तुम आप
So would
इसको,
how is A star different from A? Like how would we differentiate between A star
so
and A?
it is like excited. That's what we say.
Okay.
It has got activation energy. So this
That-
A star differs from A that it has higher energy, and that's why it is going to product. अब इसको करके देखो तो what will happen? You will get this term. You see that? Okay. Let me go and again. Right. A plus A star plus A, and A star giving you product. Okay. Now what I will write? Minus D A star is now intermediate dt. Okay. So K1 A square minus K minus 1 क्या लिखेंगे? A star into A and minus K2
A star.
is equal to 0. So what will be A star? K1 A square by K minus 1 A plus होगा या नहीं होगा? And then dP by dt is simply K2 into A star. Is this okay? Does this make sense?
Yes, sir. Just one doubt. Like, how are we sure that k minus 1 वाली जो value है वो बहुत छोटी नहीं है? Like, I mean, over here, that is the only assumption we made. That's why we were able to tell कि A will be in the first reaction. A would be on the right hand side or on the product side because of the rule which you had given, like those rules. But that is only true if we know that the k over there, k minus into A, that k minus is not that small. So if it was small, then to we would not have been able to use that, right?
In fact, you see here we are not taking K2. K2 is small, but it is
Yes,
not
sir.
very small. All right. So right now I am not assuming that K2 is small or not. Only thing I am assuming that A star is your A star is your
Intermediate.
yes. A star is means forms in a smaller amount. Okay. So that I can apply a steady state approximation. Okay, here we have not assumed anything. Apart from that, I can apply a steady state approximation and then I can write this. And dP by dt will be simply same thing, right? Because here it is getting formed. So dP by dt is K2 into A star. ठीक है? तो K2 into A star तो होगा ही. अगर हम second rate determining step लेते हैं तो this will be smaller and then I can neglect it. It will be first order. In fact, it is not first. So you can see here that when it will be first order, when I can take K2 as a small.
As
तभी हो सकता है.
so the
Otherwise,
in this general case, if we add up, then it would be A plus A gives like A plus B, right? Over here. If we are adding it, these two, like if we take the general equation from these two equations.
no, this is for unimolecular. So I didn't understand question.
नहीं जैसे कि जो पेज के एकदम टॉप में जो दो रिएक्शन लिखे हैं तो इसका ओवरऑल रिएक्शन जो होगा दैट वुड बी A plus A gives P plus A, right? Can you see?
So see here, what will be the overall reaction? This A star cancels out.
Yes, sir.
This A will also cancel out.
Okay, ठीक है.
Okay.
I thought we'll write that A on the right hand side to show the possibility of it can be bi or uni
No,
both.
so what is happening here? Simple thing. A is colliding with 1A and one of them is getting energy. Another
Yes.
remains as such.
Okay.
Okay?
Yes.
And this, the one which has got extra energy will go to product. Okay.
Okay.
This will explain everything and why under certain condition it will be the second order and why under different condition it can be first order. And idea is simply here, you see here. कब होगा first order?
When K2 is much greater than
K2 is
greater.
small
Yes,
होगा.
small. Yes, sir.
So first order.
Hmm.
And when K minus 1A is small, then
Second.
second order. Now think about if I take high pressure, क्या होगा?
Volume कम होगा तो जो concentration.
Think about this. High pressure, what will happen to this reaction? Collision ज़्यादा होगा, कम होगा?
बढ़ेगा.
बढ़ेगा. Right? So K minus 1 will also be high because A star will also collide again with A to give you A plus A. So
Yes.
both K1 and K minus 1 will be very high.
Yes.
अगर K minus 1 ज़्यादा है तो इसमें क्या होगा?
तो K2 को नेग्लेक्ट कर सकते हैं.
K2 को neglect करोगे. Then it is
First one.
first order. And what happens when you are dealing with low pressure?
K minus 1 छोटा होगा.
K minus 1.
Will become small.
So that's same thing, you know. So he was able to prove that at low pressure, the order of reactions, which is first order generally, which you see as a first order reaction at the atmospheric pressure, if I take that to a very low pressure, then it becomes a second order. Because this K minus 1 decreases, so this one can be neglected and then it becomes second order. In fact, lot of second order equations which involve certainly one reactant, then इसमें क्या होगा? Same thing, you know, that it will become first order. So first order under which condition? So first order, if room temperature पे first order है, room sorry, atmospheric pressure पे first order है, तुम pressure घटाओ, if you decrease the pressure, collision will decrease,
It will become
and
second
collision
order.
will decrease, then K minus 1 will
Decrease.
decrease. So if I neglect this, then this becomes second order. Second order. Lot of first second order में क्या होगा? अगर atmospheric पे second order है, then if I increase the pressure, then it becomes first order. Certainly that involving one of the only one reactor. So that's what he generally showed this first thing, that at atmospheric pressure, if it is first order, then if I decrease the pressure, the second. But there are some example known where at the atmospheric pressure, if it is second order, I increase the pressure, means I'm trying to increase the K minus 1 value, and so this will be neglected and then it becomes first order. Is this clear? So you see, unimolecular reaction was explained by, you know, this Lindemann through this mechanism. There are another way to explain this. Think about that A not colliding with A, then what will it may collide with M. M is suppose a surface, or M can be a catalyst, something like that. Okay, and then A star plus M, and then A star gives you a product. Now, can you tell me what should be the rate law? What should be the rate law? नीचे क्या होना चाहिए?
नीचे M होगा.
M होगा. दो स्टेप है तो इनफैक्ट जो मैंने रूल कहा है, इससे तुम्हें स्टडी स्टेट सॉल्व करने की भी जरूरत नहीं है. यू कैन राइट योरसेल्फ. यहाँ पे क्या होगा तुम्हारा? सम
K into A plus A into M.
A into M.
Yes.
करके देखो. सॉल्व इट. यहाँ पे क्या होगा? A स्टार into M.
M.
And तो K2 into यहाँ पे A into M होगा. Am I right? K1 into A into M. Am I right? minus K minus 1 A star into M and minus K2 A star. Now tell me what you will get A star.
A1
यही आएगा
A M yes,
A
sir.
into M K minus 1 होगा certainly यहाँ पे K minus 1 A into M by नहीं K1 into A into M divided by K minus 1 into M plus
K2
K2 होगा ना?
yes, sir.
Okay. So this is the way you can know. So जो मैंने तुम्हें रूल बताया रूल के हिसाब से you can even write your rate of equation. You don't have to solve everything. अब मान लो यहाँ पे A star plus C होता तो क्या होता?
So
But
that instead of M, it would be C.
नहीं M okay यहाँ पे मैं देखता हूँ okay A star plus C तो क्या होता? M तो होगा ही यहाँ पे एक C आएगा
Yes,
सी
sir.
टर्म बात है
A आएगा ना C यहाँ पे K
Yes, sir.
डबल डैश के बाद
Yes, sir.
Yes, sir.
तो इनफैक्ट तुम लोग प्रैक्टिस एक बार कर लोगे तो इनफैक्ट यू डोंट इवन हैव टू यू जस्ट सी द मैकेनिज्म यू विल बी एबल टू राइट रेट लॉ with the once you understand the concept it is very easy. Now you understand why some reactions are unimolecular although there will be collision. Without collision they are not going to get the activation energy, they are not going to get the activation energy, they will not go to product. Am I right?
So, but in this case, we are not talking about any decomposition reaction, right?
नहीं कहाँ decomposition नहीं है.
नहीं मतलब
A star is going to P simply.
if A decomposes to give suppose like P plus water and we neglect water because it is in the medium, then
That can happen, but we are right now we are not considering. Product can be anything. That can be a 2 species. It doesn't matter. Rate law will not change on this product here at least
yes.
at this stage because rate law is always dependent on reactant, not product. Unless product is involved in the, for example, if there is some product here and then they involved in some step, then that is a different case. But otherwise, it is not, not involved in any of the, means rate law. It is not, its concentration will not affect the rate of reactions. Okay. So see, several of such kind of mechanism was derived using kinetics. Okay, using kinetics, they derive what is the rate law, what can be the mechanism. Just look at the experiments. For example, here they looked at the mechanism and they come to know that under certain condition it is the second order, under the different condition it is the first order. In that case, certainly, I can write rate of reaction like this. And what they did, what Lindemann did, he changed the pressure. And then he saw that, it is first order reaction at atmospheric pressure, but if I go down, then the same reaction becomes second order. On that basis, he proposed this rate law. On the basis of rate law, then he proposed the mechanism. Is it clear?
Yes, sir.
Yes, sir.
Okay, so let me give one more example and then I will start. Okay, for example, take this reaction. PH2CHCl plus H2O gives you PH2CHOH plus Cl minus plus H plus. So this is your total reaction. And then he, this was the experimentally observed CHOH by dt is equal to alpha. This is rate constant, some constant. Alpha is some constant, CHCl by beta plus Cl minus. Okay. Now tell me what can be the mechanism. How many steps?
At least two.
2.
2 steps, at least 2. Yeah, keep that thing in mind. Okay. Okay. Now tell me, Cl minus is reactant or product? Is it reactant or
Product.
product?
Product.
तो कहाँ मरना चाहिए?
Product.
In the first.
First step.
First step.
Yes. Is this okay?
Yes, sir.
Yes, sir.
Now think about this. इससे क्या होगा? So second step ये होगा तुम्हारा, because Cl minus in the first step, तो second step में ये होगा. It doesn't have concentration term. So suppose I neglect this. क्या बता सकते हो यहाँ intermediate क्या होगा?
PH2CH plus 1.
Is to CH plus.
1.
It's quite simple, am I right? is to CH plus. इससे तो यही होगा. What you should get
PH2CHOH plus
OH.
H
क्या involved?
H2.
plus H2.
Plus H2.
H2O will not come in this thing. That's what I discussed that day. Right? And so here composition will look different, but you neglect this thing. And plus H plus. Right? So it is quite simple to write. So it is not that difficult. Only thing is that bit of, for example, here you have to think of that water must be involved, must have involved. So I will give one question, try yourself, and then tell me in the next class whether you are able to do or not. So this is I minus, please write down. OCl minus, we have class tomorrow, am I right? IO minus plus Cl minus. Rate is equal to K I minus OCl minus by OH minus. You try करना and see whether you are able to get the mechanism. Okay, keep that thing in mind that water can be involved in the mechanism. Is this okay?
Yes, sir.
Okay, so think about this and solve it. Tomorrow we will discuss in our class. Okay. Any questions? Anybody want to have a question? Just let me know. Otherwise, I will stop. Okay, no question, then I am leaving.
Thank you, sir.
Tomorrow at 11, am I right? Tomorrow is Monday class, am I right?
Yes, sir.
Okay.
Yes, sir.
Okay, thanks.